Hello, welcome to another Donkey Kong Genius video. Today I'm going to demonstrate what it means for an NES game to initialize its memory. And today I have an example for NES Metroid where the ROM initializes or stores a value into RAM. I have two memory addresses here. One is we're going to look at is going to be initialized, but another one is not going to be initialized. And we're going to see how this has influenced the starting pattern of enemies and other patterns going forward. So whether you're using different emulators or different front loaders and so on and so forth, we're going to take a look at exactly why we get different starting patterns for these different things. And it has to do with an uninitialized value. So to start off, I am using a version of FCUX that allows us to establish different RAM states as its default. So what I'm going to do at first is I'm going to use the default of FCUX, which usually is a 4 RAM addresses with a value of 0, followed by 4 RAM addresses, followed 4 RAM addresses with 255 or FF in hex, and it just rotates like that. So with that default, we're going to advance forward. I'm going to draw your attention first to the memory address 002E. On this particular frame, you'll notice that this value becomes initialized by the ROM itself. And as a result, we are going to get the value of 17 every single time, no matter what system you're using. Power Pack, EverDrive, top loader, front loader. It's not going to matter because this particular value is being fed into RAM by the ROM itself. That is, it's initializing the memory. That's what the ROM code is doing. So we're going to see this value of 17 pop up every single time. However, you'll notice that the memory address 002D did not initialize. What this means is that whatever value is in this memory address when the system starts up, whatever that default value is for top loader, it's probably a very consistent value. With emulators, it's going to be a fixed value. But with various front loaders, it's very possible that within the first few years of its manufacturing, the memory is probably not as consistent or as reliable as later models. And so there is what is called memory bleeding that can take place depending on how long it's been powered off, can influence this value, so I've heard. And so going forward here, I'm going to advance and to see what happens. The frame counter is actually the 002D, but if you watch, we're going to notice that it's going to advance from 255 and then it goes over to 0, and then it's going to continue to move forward. Now, if we were to do a random initial state, in which case, if you're using this version of FCUX, by the way, if you've never used it, it's kind of an interim version of it that has this RAM initialization under config that allows you to change what the default initial RAM state is going to be. And so what you can do is, if, for instance, you're interested in this particular version of FCUX, please let me know. I'll try to get the ROM file to you. Not the ROM file, but the program file to you so that you can use this. And you can test to see, using this test by changing the initial state, you can determine or find out if a particular RAM address is not initialized by the ROM, and you can kind of extrapolate from there why certain things occur when they do. So when I click it to random, let's see what we get. So in this case, we're getting a value of 67 and 155. So we're going to advance forward. I'm using the task editor function in this so I can do it really slow. We're going to watch the initialization of 002E become 17. Once again, this is a fixed value in the ROM that gets put into the RAM. So this starting value is always going to be the same because the system is getting this value from the ROM. It's being stored into that memory address. But we're going to take a look at 002D, which is said to be a frame counter, and we're going to advance forward and see what happens when a different value other than 255 and 0 is in there. If it's 255, it's going to advance to 0, then 1, 2, 3, and so on and so forth. If it's 0, it's going to go to 1, 2, 3, and there's going to be there's that one value divergence. So the comparison that takes place between, say, 255 and 17 versus 0 and 17, there's going to be a different computation. And so therefore, it's probably going to be a different so-called RNG path. If those who are not familiar with the Japanese version of this game, it is very much RNG, where there are new calculations that are occurring every single frame while you're playing. However, with the US version, it's kind of broken. This particular function is broken for some reason, whereas the very first computation that occurs of these two memory addresses fixes a certain outcome, so that it doesn't matter what these values change to, you're always going to have this same outcome going forward. So if we can get or determine a very specific starting value, then you'll be able to always get a bad pattern based on power on, or you'll always get a good pattern based on power on, and so on and so forth as a result of this. Otherwise, you'd get varying results whether you powered on or not. All right, so watch this memory address 002D that was not initialized. The default value that we started with will continue. As you see, it's going to begin to increment just like it would if it were a frame counter, by 1 every single frame. So what this means is that the comparison that's taken place between these two memory addresses is going to be dependent upon the initial RAM state of your NES. So once again, this is an example of when a memory address is initialized by the ROM itself. In this case, it becomes 17, and a memory address that is not initialized. So whatever the value of that memory address in the RAM is by default or at the present moment is going to be determined, is going to determine its value going forward. As you can see, it advances, increments by 1 every single frame. So that's why you're going to get a different calculation, because it's a different comparison, and that's why we're getting different results when it is different. For Power Pack and EverDrive, for example, this value is probably being fixed to a certain value as a result of the operating system that gets loaded into the system. So if the Power Pack or EverDrive flashes the memory to a certain, sets it to a certain RAM state, or the value is being changed by the operating system to a specific value, you're always going to get the same outcomes, because this memory address is always going to be fixed. It's going to be fixed either because it's setting it to it, or because it's being changed to it as a result of the operating system. So you're always going to get, say, a good pattern. So I hope that you like this kind of introduction to memory addresses being initialized and being uninitialized, and how that can influence outcomes. If you have any questions, please post them in the comments. And if you haven't already, be sure to follow. And I thank you for watching.